So yeah, I am an engineer at Incident.io. I've been on the AI team here for like the past year or so. I've been at Incident for 2.5 years. So like as part of that, I've done a transition from boring SaaS engineering to something a bit more non-deterministic and hard to understand. And this talk, I hope, will sort of like give some insight into like what that was like, how we did that as like a team together, and like how we sort of socially adapted to the fact that we weren't just writing like API endpoints anymore. But yeah, like what is Incident.io? Like, I mean, you're in your office and you've obviously heard us talk about sponsorship stuff, but I think it's like interesting to actually say like, what is the context that we're doing this AI engineering in? So like, I have parents, they're not site reliability engineers. So when they ask what I do, I'm like, imagine something went wrong at work and you like noticed that thing going wrong and you kickstarted the ball rolling up until the CEO is getting like told that he has to deal with this thing. And like when you noticed this thing going wrong, how did you sort of like structurally as an organization begin that like, oh, that thing looks off to this is a 5-alarm fire, please wake up sort of like experience. And basically this stuff happens quite regularly. Incident helps organizations sort of like run that process, learn from that process. It helps wake engineers up at 3 a.m. when the database is down. And like we build a sort of like we build a sort of repeatable engine to sort of deal with things when things break, which is all the time. So yeah, like we're privileged to work with some pretty cool customers. Like we've got Lovable if you're into Swedish AI maximalists. We've got Trainline if you're one of the 5 million people that use a train each day. And we've also got Netflix if you've ever been bored on a weeknight. So like there's a whole load of them. Yeah, so when we say incident, that can be anything from a user hit an error to we have been hacked and we need to tell everyone that has happened, right? So like, I'm sure a lot of you have sort of experienced this in the past like year or so, and like incident that was sort of no different, right? Your CTO comes to you one morning and they're like, you know that roadmap you loved? Well, say goodbye to it. We're making an AI bet and you need to do that right now. And like, that is basically how our story begins as well. The reason for that is basically AI is like an existential threat to our current products. We help you run incidents, we help you like navigate the human work to do that, but there are a whole load of like ambitious people on the market at the moment, and including ourselves, who like want to solve incidents for you as opposed to just helping you run them better. So like as opposed to just saying like, oh yeah, I've managed to find what the error is and I've raised a pull request, that just happens without you noticing it, right? And like one of those is clearly a more attractive option to the engineering leader. So we needed to basically have a credible answer there. Like, yeah, like we needed to have a credible answer to this. And like, not only is it because of competitive pressure, but it's also simply because like, this is a pretty legit product. And if someone's gonna build it, we'd like it to be us. And the reason that like incidents in particular are like at threat from AI is like so much of the work in incident response is sort of like automatable and repeatable. There's so many occurrences where a user gets paged and they're like, oh, it's that thing again. And they just run the same workflow that they did last week. And like, that's just like quite annoying. And like, there's a reason that the human has to be in the loop, because that 1 in 50 times it's actually different and you have to run a different run book. But like, this is just like quite a repeatable and tiresome, and like you just see the same things a lot. And the other problem with this is like that knowledge is like extremely siloed. So like it usually exists in a few people in an organization's heads. They have to be woken up, interrupted, they have to context switch into the incident and then do their thing again for the umpteenth time, right? Like, if we can sort of break down the silos using sort of like, well, the subject matter expert here is Matthew, and when AWS goes down, although you're having a bad time, if it's like limited to these services, you can do that. Like that sort of thing is just like something that we can help our customers have a better time of doing, and we can sort of relieve the stress on these people that are usually important and blocking in their organizations. But yeah, so like, I don't think any software engineer really enjoys truly answering the question, what do you do, right? The answer is, I sit at my desk over there, I write code most of the time, I might go and do a meeting now and again. And like, that used to be the answer, right? I'm obviously not the first person to point out that AI has implications on software engineering, but it is just worth considering for a second. So I don't know if any of you have ever seen this graph. So the ONS does this thing every so often called the time use survey. And it's quite a great measure of like, what is actually actually going on in the world. And the way that you do this is you just ask people at different times of the day, like, what were you doing at that time? And you can sort of see the wake up and merge, the working day, and then you can see people shutting down at the end of the time. And like, if you do this on a population basis, you can just like roll up this large view into like what we're actually doing in the world. And I think if you like sort of surveyed individual engineers on my team, and we did our own version of this time use graph, which truly, if we wanted to be loud on LinkedIn, we should have done. But like, just more and more of this, you are not writing code and you're instead talking to like an agent or Claude Code or like a cursor or something like that. And the actual mechanics of your day-to-day work in the past year has just like completely transformed. And like, I think if we were being truly honest about ourselves, like that's quite a mad like challenge to go through. And it sort of requires quite a large upheaval and understanding of our work and engineering and what mattered and where we needed to pay attention. And like, yeah, just basically like, it's been transformative for good and for bad. And I'm gonna like share what that was like for you. But like, this is not gonna be a talk about, oh yeah, Cursor and Claude Code are pretty cool. You don't have to write code anymore. You don't have to remember syntax. Because I think most people sort of like either agree with that or have been exposed to that on some level and like understand that that's happening. And that's not crucially like what AI engineering is. Like AI engineering is the practice of taking these like technological advancements and working with them every day and like sort of helping your organization build products that take advantage of these technological advancements. And we're building experiences that weren't really possible like 2 years ago, right? And as part of that, we've realized that like this is a very different role, and the sort of like old tool set for software engineering maybe doesn't like matter any, or isn't as applicable here. It does matter, but it's not as applicable. The old tool set of developing features and then rolling them out and monitoring the performance with traditional observability and analytics, these processes were like designed around an old style of application and fit this old workflow. And it was really, really, really good. But there's been a change in what like the engineering workflow looks like and the products that you build and the sort of technologies that they use. And as part of that, like we've had to shift everything as well. So yeah, what is an AI engineer? Well, it's a quantum super, it's obviously not, right? Like the answer is an engineer that builds apps that call large language model APIs, right? Like that is truly at the end of the day, like what we are doing here. We are working on apps that call foundation model APIs. And like, this is both absolutely true and facetious because unfortunately that's actually really hard, right? Like these things are like, well, some people would tell you they had minds of their own, right? And they're completely non-deterministic. These things change all the time and you have little to no guarantee about the response or experience that you'll have with a given API call. The main interface, the prompt, is a weird and wonderful thing. A small change in how one part of the system, which to be clear is overall non-deterministic, can affect overall system performance massively in a way that's no longer measurable through standard performance toolkits that engineers use. You also have to think about the product experience here. Every interaction that touches these systems now has a meaningful interaction latency. We've never really had to think about this before. We're used to our like 20 ms response time, right? And now we have latency, and that's weird, and it means that like user interfaces that worked 2 years ago don't work anymore, and we have thinking states as well as loading states, and this is really, really weird. Like actual clicking the button responses in Dashboard or in Slack now have like a variable amount of latency to result, and it's just like, it's really, really weird. And customer onboarding goes from like polished design flow where you sign up and you enter your credentials and stuff like that now, to if you're doing some sort of AI product, you maybe have to run a large background job. And like, how do you monitor the progress of that background job? How do you know when it's failed? When it's restarted? Is a user in a half onboarded state? Like there's a whole load of things that you need to think about here that are just like not in the minds of your average SaaS engineer 3 years ago. And that's just the slice of the sort of day 2 challenges. I could write 100 of these problem statements. It's really, really different paradigm to wrapping your database in a web application. But why is a separate role? Well, part of this is like when an industry is under a lot of stress, it just gives someone a new title and that will solve the problem, right? We have this person with a title now and those problems no longer exist. But also like just candidly, like the prompt interface is really, really strange and not everyone enjoys the experience of working with them. And rightfully so. I wasn't sure, still am very happy writing web applications, and I'm not sure even like working with large language models. A year after the fact, I'm really not sure if I still enjoy this. A colleague of mine, Adrian, last week experienced an issue related to alphabetical ordering in a prompt. This is absolutely stupidly annoying, and the tenacity to push through that is just like simply not mine. It's a different and unique skill set from normal traditional engineering. And I remember when when this all first sort of like started, really the hype kettle started to really chatter, Scale AI, who have since been acquired by Facebook, had this guy on Twitter that was calling himself a staffed prompt engineer. And I thought it was completely stupid. Like, that's the most ridiculous hype thing I've ever seen in my entire life. I'm now not sure if they were wrong. It could be a completely legitimate job title. It's just very, very different to sort of traditional software engineering. And prompts are bespoke enough with sort of an internal logic that you can't really ask a large language model to write it for you. You actually need to write these things with your actual hands. For example, imagine you're working on a search query generation. You're stressing the fact that the user might want to search by date too much on line 72. If you change that sentence from it's likely that users will search to date to sometimes users will want to search by date, the test rate, pass rates will jump up significantly. This is just not available on Stack Overflow. The learning curve is steep here, and the only real corollary I can think of to prompt engineering is like, if you remember close reading at school, do you remember stressing the importance of iambic pentameter? And you had to say, well, the fact that we're using iambic pentameter here suggests that the writer of this poem believes that. That's kind of what prompt engineering is like, and it's not just like writing Golang functions anymore. So yeah, if I was to go through a sort of timeline of what happened here, this is my timeline. So, and with all good theme parks, it has a you are here arrow. On one axis here, I have time. On the other side, I have something that's even more inevitable than time, which is your self-perceived progress towards a goal. The timeline here is about a year, and everything before solving scoring happened is the first third of that year. The rest is us doing development on a system we can actually work on and gain more and more confident as we did. You can see here that there were lots of ups and downs here, and some were sharp, and plateaus. And the plateaus are actually the worst bit, because when you're on a line that's plateaued, you don't actually know if at the end of it you go up or down. It could be the case that you've just reached a new rate of progress, and that rate of progress can continually trend upwards, but it could also be the case that you're on a fundamentally wrong approach and you don't know that you're eventually going to crash into the ground. So yeah, like I'm going to just do an overview of what it was like on each of these things and how we sort of like broke through them when we did. So yeah, back to what we learned. So here's a screenshot from the 6th of October in 2024. It's one of the earliest versions of what we eventually called AI SRE. It looks pretty good, right? The Slack message here could obviously be a lot prettier, but look at what we're doing here. We're finding an incident that looks similar to someone using Skim, which is a way to provision seats in the SaaS application. It's trying to remove the last owner of an organization, and we can't have that because we don't want an ownerless org. So we have the steps to resolve and some debug information about how we did this. And this, to the person that's paged at this time, is actually really, really useful. But I have some really bad news about this screenshot. Well, like, remember when I said that we take a really sharp drop after the good bit here? That's this. And the problem with that screenshot is almost everything was completely unprovably good. While the end result was good, we had no ability to tell if the vector multiplication gods had looked kindly upon us. We could have just been extremely lucky. We had no measure of performance beyond looking at the message. And if you look deeper, we're repeating very high level what did we do instructions. There's nothing material below us at the surface about what we should do in this context. And also, finally, we have no idea at all about how we reached this conclusion. Even this early system was complex. Which constituents parts we did well, we honestly couldn't tell you. So we were very encouraged by early progress here. It felt like we could reach out and touch the thing we'd always wanted to build, but this promise was balanced against a slow, painful, and unscientific development process. Every change required a full run of the CI/CD pipeline and crossed fingers. We had no way of validating the changes we were making were good, either locally or in production, and we had no ability to break up the investigation into its constituent parts. And the worst part was when something did well, we had no idea which components had actually performed well. But, as if by magic, an oasis on the horizon appeared. No, really, we just read a lot of blogs and talked to a lot of people in the space, and it started to really dawn on us that we were going to need to build a lot of tooling to build the system, and the emphasis is on to build, not to monitor, and not to assess performance. If we were going to build anything at all, we needed to build this tooling. There's just simply no other way to do it. And that's what we did, and for the rest of the talk, I'm going to show off some of the tooling that we built and how we reasoned about it. So yeah, just a reminder, we're at this bit, and this was a good bit. So the first thing we reached for, and if you read any guide on building LLM systems, this is step 1, chapter 1, if we got some evals. And evals are great. They're basically the unit test of large language models. You define some input, as in what would be going into the prompt in production, and then you would define some desired output. And then you have checks that confirm that the desired output matches the actual output. And you can slice these checks any way you want, and I'm going to show you a worked example from our production eval suite. And like, I think that The thing about these evals, though, unlike unit tests, is sometimes they do require a fundamental advancement in machine learning to be able to pass them reliably, and you just have to deal with that. So yeah, I never thought I would be a man on stage staring at YAML, but I am. You can see that the eval's name is asking for clarification when escalating. So you can see here that what we're testing the fact is there are 3 Rorys in our organization, and that we don't just page the first Rory that we find, and that our bot is smart enough to ask a clarifying question. Paging the wrong Rory would be really, really bad. My phone could go off right now, and that's what this eval is guarding against. And then this is what a check looks like. So we're using something here called LLM as a judge, where an LLM checks its own homework. And what we found is that is materially harder with what is found is that is materially harder is all the issues you have regarding how is this LLM performing re-emerge. You almost have to do evals for your evals, right? And like, it's much better if as with all things, if you can just write some code to check that this string matches this string, as opposed to having to reach for a harness like this. Unfortunately, I have to tell you, to quote a really bad Pierce Brosnan late 90s Bond film, that the evals are not enough. You know how I said they're like unit tests? Well, they're also like unit tests in that if you find out your entire reliability and product quality strategy was based around unit tests, you'd be a little concerned that your organization was using unit tests like that. And the answer, for a lot of the same reasons that we just don't use unit tests for reliability, is we also can't use evals to test complex AI systems that have multiple components that all chat to each other. Correctness metrics here are much more, did we actually solve the problem, than did this one component succeed? So we found these really hard to operationalize, like having all the problems of having a bad test suite, but much, much harder. As opposed to just writing some API contract or changing the input type of a parameter, you've got to rewrite something in prose to match the exact example you're testing. And because of this, we'd end up crafting gimme evals that didn't actually match the complexity of customer interactions. I mean, if you look at this, for example, there are absolutely no prizes for determining that this particular conference talk isn't going very well. But if you have evals like this in your system that you think that suggest that you maybe think that you are good enough at like working out if a talk's going well or not. This is in some ways worse than no evals at all, right? It's giving you false confidence that your system is performing in ways that you aren't actually hitting in reality. And now we moved on to the good bit. So we take our evals out of our development environment and into and from the real world. So we basically test in production. And so I don't know if anyone has ever come across the writer Charity Majors, but she writes a lot about how testing in production is actually good, and you should stop being ashamed of the fact that you do it, because you do. And she's so proud of this fact that she has stickers. And while we take our tests in production too, we've made it easy for our engineers to deploy an early version of a feature, try to use it, watch it fail, watch it all go wrong across customer accounts. And then we import those examples from customer accounts and our production examples into our eval suite, and confirm after repeated rerunning that the results we're seeing are actually a genuine failure. And then what we do is we take that test that we've imported from production and we hill climb it and iterate against it until it passes every time. And this works so much better. You don't have to handcraft examples anymore. You don't have to be a writer. You just copy it from production. And we can now drill down an investigation into an incident and see the constituent parts. So this is a view from our internal dashboard that allows me to see how when our system runs, like I can break it down into all its individual components. And this is where I copied like examples from. And yeah, so I can see this, the end result came from, and I can see as this like investigation progresses, like what changed on the input and output of each step. And it's really, really good to sort of see how something's evolved. And you know, when I said earlier that the old workflows didn't work, well, I was lying. This is a trace, but a trace of a complex LLM-based system, and this helps me slice and dice the trace easily to see exactly how we got to the right answer. And yeah, it totally kills the sort of like, but how did we actually get here? How did we reach that conclusion? The answer is you just break it out and you view it like a trace. And when we batch these up and run them in something that we call a backtest, so this is an example of two problematic incidents that we previously had in our system that we were unable to sort of like, initially we didn't get the right answer here. So what I'm able to do with these is copy these investigations that we ran and the whole context that was initially fed to them at the very beginning. And I can tune and tweak the system and then run this again and again and again and again, and I just can see these numbers rising. So eventually the sort of like, what happens here is we have these things called data sets, which are a collection of incidents, and we create this data set and then we score how well we performed, right? So this is our like signal and precision report. And then from this, I can sort of iterate and see over time how we're progressing as we change different parts of the system. But surely that doesn't scale. And then, yeah, we have extra context in our organization because we know how our developer tools work and what the layout of our organization and system is. But like, what about the people that actually want to pay money for this system? How can you make sure it runs well on their account as well? Because in the customer context, it's totally different. We don't have this access. We're pretty blind. So we need something bigger here, unfortunately. And so as part of the thing, So as part of the thing, when we built an automated scoring system to assess our performance, this is when things got really, really good. And the downward curve here is us actually implementing the scoring system. But you can see that the downward curve eventually is matched by a bigger upwards curve. So it was worth it. But yeah, so back to scoring these things. Scoring is incredibly difficult, but also incredibly important. We have to have the absolute trust in those metrics I showed you at the top of that backtest page, so that we can actually understand how we're actually doing and that point engineers in the right direction of when things are going wrong and where things are going wrong. And it's important to understand just how hard it is to score this thing. For example, we care about, as I said, caring about our investigation at the beginning of an incident. So how do you know that nothing from the future in this sort of backwards compatible test environment has leaked in from the future and is now making your investigation much better? For example, like, you just won't understand how many vectors there are for that to occur. So imagine we're looking at PRs to see which pull request in GitHub caused a given incident. And what happened was one of your engineers renamed that after the incident had occurred. We need to make sure that we're scoring against the right title, because that was the information we had when we were running the investigation at the beginning, and some sort of like future data didn't leak in and poison the whole interaction. So yeah, like, as part of our scoring system, we've had to build this cutoff system where we can sort of travel back in time to give ourselves an honest reflection. And as well as our scoring systems have become like a reliable sort of source of like how well we're performing, but like, we're still finding cutoff bugs where there's accidental leaks of information from the future that we should have caught. So we have a number of AI surfaces. We have like interactions, which is like us adding our chatbot. We have the investigation system, which is that thing that tells you what has caused an incident. We have things called suggestions, which are running, which are like, it looks like this incident name is stale, and we think you should update it based on the content of that incident. And every single time you have like a new surface area like this, you have to write a new scoring rubric as well. A good investigation won't make a good chat interaction, and you can't have these be general purpose. They're just fundamentally different pieces of information that are scored differently. And then you run your scorer in production and you're like, oh look, we're doing great, those results are really, really good. But then you actually click into them and they're doing bad and your scorer is actually wrong. So you have to prompt engineer that all over again. And like, this is just a bite-sized, like, simple view into some of the problems we've had with this. It's absolutely maddening, and I could have gone through like 20 or different systems that we have that like we experienced there. But yeah, we're now here, we've released this to over like 50 customers. It's live in organizations, working away, and it's getting better all the time, and we're really, really excited about. So I'm going to end with some like general advice to people that are like having to work with AI or having a team of engineers that are also working with AI. So yeah, the only way out, so how do you deal with non-deterministic systems? And you run things so many times that you basically have deterministic systems. I kind of think the best correlate to this is opinion polling, which is weird. But if you go into the high street out there and you ask the first 10 people what you see, what do they think the country should be, you're not getting a general representation of the true population. You're just getting the people that drink at the Angel on a Thursday, as smart as they are. But what you need to do is sort of opinion poll your production experience and get your eval suite to the point where you have a representative sample of how you're actually doing and how you respond. And then you need to tune your prompts when they're satisfied with how well they're performing. Yeah, you just need to run things like 150 times and take a sort of representative sample of actual output. Yeah, and like, what's the hardest thing about writing code for LLMs is that the code organization really, really matters now. Abstractions are no longer free, right? Like, if you are dealing with something that is less smart than an actual engineer, and when I wrote this talk 6 months ago, maybe that was true, but maybe Opus 4.5 is good enough now that you don't actually have to do it. But like, when you're giving a large language model an abstraction, it's not smart enough to sort of know the context of like, oh, when you call this function with this thing, it actually means that. Like, you have to give LLMs clean abstractions now, because the self-discovery of what's going on is like matters a lot to performance. And you have to just be very, very careful that the abstractions that you have in your code base actually reflect the actual reality, because if the LLM's missing context, it'll use them incorrectly. Yeah, a lot of the time we hit like what we think is like an upper limit of LLM capability with regards to tool calling, for example. And if you just rewrite the tools, like the abstraction layer of the tools or the description or the name to actually reflect what it's doing, you can eke out extra performance. And just like be careful that the things you're actually dealing with actually reflect the task that you want them to do. And then can't you just buy like a system like this off the shelf? Like, can't you just buy like a braintrust.dev or something like that give you this sort of LLM observability tooling? And the answer is we've had to build this internally because we had to. We deal with very, very sensitive data, and our customers will not let us send this information to anyone else but us. And if you can get around not doing this, you shouldn't, right? Like, you should probably buy Braintrust or OpenAI. Their own eval products are really, really good, and if you're interested in this, you should look into them. And then this seems really, really tedious. Why continue? And the answer is that complexity here is a moat, right? Like, the answer is we just banged our head across it, like, along this, like, a lot, and we hopefully got something that was better at the end of it. And if we have to spend hours and months and days, like, trying to bang our head off making this system better, hopefully our competitors will too. And we didn't start with anything near the system that we have right now, and every single, like, quality improvement we've had has been, like, us just running things, watching it break and dealing with it. But yeah, that's the end of my talk. Thanks for coming to listen to me rabbit on. As we said earlier, we're hiring. We build this stuff with colleagues in person in this room over here. We're looking for more colleagues too, and we pay money if you know anyone that would be interested in this stuff. But thank you.
Thank you very much. That was absolutely exceptional. I'll definitely be getting you for DevOps Day. So, has anybody got any questions for Rory? No? Yeah?
How much of your engineering team are building AI products right now?
About a third. So the way that our engineering org splits out is that it's by product. We have a response product, about a third of engineers on that. We have an on-call team product, about a third of engineers on that, and then about a third of engineers on the AI product as well. The skew of like tenure and seniority or whatever like is mixed up there, but like that, it's about that. Yeah. Yeah. Yeah.
Are the AI engineers and the product engineers one and the same in this company, or are they completely different departments?
So the answer to that is everyone here has the title product engineer. In reality, skill sets are obviously very different, and different people do different things. So I have a colleague called Millie that just does prompt engineering all day. I don't really know why she does that, but she's very good at it, so we just let her do it, and we're happy to have her do it. And like some people are more prompted than others. So I work more on like systems that are adjacent to our AI products. Like at the moment, I'm building something that lets us tunnel into customer networks, and that's exciting, but like that's to enable AI stuff. So like the mixture of skill sets is like very different, and I would say about a third of the team are like core focused on actual AI systems, and the rest are supporting infrastructure. Does that make sense? Yeah.
Yeah, when you said prompt engineering, do you mean she's vibe coding?
No, so all the harnesses that we've built here are to support this sort of system. And like the type of thing that Millie is very good at is like when we have some like tool infrastructure that an agent has, she's like very good at like looking at 50 examples of this thing absolutely going wrong in production and finding like the common theme of why that went wrong, and then changing like the architecture of the agent system that we have, maybe showing new information that or previous context that it didn't have that's important and essential to us doing this. Like there's a whole bunch of like, the failure mode's really, really weird, and the honest answer is sometimes you just have to change the API or the harness or what information you're showing and when, and she's just basically very good at doing that sort of stuff. She comes from like a research scientist like background, and it felt that that type of skill set is like weirdly actually like really, really aligned with doing it. It's a lot of like looking at Excel sheets of performance and stuff like that.
Okay,
Cool.
Engineering, like let's say personality traits or engineering traits, did you see a difference between AI engineers and SaaS engineers?
Yeah, so I think the tolerance for boredom is like if you guys thought API endpoints were boring, this stuff can be real tedious. Like I would simply say like the sort of cycle of reward or feedback is often longer and more undetermined than it is when you're writing code. Like if we're writing some code project, I can sort of begin to see the skeleton of something emerge and be like, I think this will take us a month. And like just the feedback cycle here can be way, way longer. And then all of a sudden you have some brainwave about how to solve it, and that eventually clicks into place. But then when you do a model upgrade, so you move to the presumed smarter model, you upgrade from GPT-5 to GPT-5.2, and the thing falls over again, and you have to start all over again, right? But like that type of thing, like often the case, like a new model comes out and it's like, this thing is the smartest thing you've ever seen, and you upgrade to it and performance gets worse because you've written a very bespoke system that dealt well with a previous model, and to like eke out that extra performance, maybe your tool calls can get less weird because you're having to deal with less model edge cases, but part of on that simplification journey, because you've got a smarter model that can call tools more reliably now, you have to change how the entire architecture of the system. So like stuff like that, if you're prepared to do that type of like tediousness that doesn't have a sort of like, yes, right answer, like that's the type of person that's good at it, yeah.
And just one follow-up question,
Yeah.
sorry. Like for example, the way you explained it was really easy to understand. So if you were to compare like the amount of hours,
Yeah.
I understand the feedback loop is it's much more tedious and you got to keep on doing it back and forth again.
Yeah.
If you were to compare the aggregate hours in terms of productivity, would
Yeah.
you say what percent do you think it increased?
I think basically the issue is the tool set and the sort of like the tooling and the understanding and the perception of how these models work, that the productivity of those types of engineers is just simply much lower than SAS engineers now. I mean, like in the aggregate, like it's a much more valuable productivity to have. So right, you'd take an engineer that could do 20% less changes on these AI systems simply because the reward is much, much higher. And like, it's a real competitive advantage for us that we have Millie that sits in that seat over there. But like, it's simply much slower and the time horizon of projects is much longer, right? Like, does that answer what you're trying? Yeah. I'm not, to be clear, if Millie watches the recording, I'm not saying she's less productive. She's actually extremely productive. It's just in a different domain that is more glacial. Yes. Yeah.
Have you tried the prompt optimization tools like DS5?
We had tried them a bit at the beginning, and then I think maybe as we were starting out with the SPI, like it just felt, it was really hard to corral into it, and we spent like a few days working on it, and we didn't make immediate progress, so we dropped it. The answer is like potentially, eventually, we will sort of like resume that stuff. There is one paper called Tau Bench, which is a way to like assess agentic performance, and we're becoming more and more Tau Bench pilled, for want of a better word, and we sort of like think that type of the optimization and performance techniques, like that's maybe where we'll continue to pull. Yeah.
I was very curious about how you got out of kind of eval hell
Yeah.
with the scorer, because you're building like an LLM judge, or you're building LLM output on top of LLM output.
Yeah.
So was it like you started and then, like you said, when you run non-deterministic things enough times, it kind of becomes deterministic.
Yeah.
You like got to the point where the outputs were fairly standardized.
Yeah.
And you're like, okay, we can actually move on to scoring them, and then.
Yeah, so that's kind of like what worked, and like, well, so what I was trying to get out there, maybe didn't explain well enough, is that you still do need evals at every step along the way, right? And that's like how we like sort of monitor performance, but the system in consortium was just too complicated at the top level scale that we needed something new that was an active measure of performance, and like that is why we went for scorers, because like previously we can sort of, those metrics there are the most simple metrics we have, but we can sort of slice and dice like different types of checks on how they're performing, and we can write checks for very specific parts of our system to do the scoring, and like, so we moved away from the like actual eval harness into this sort of general sort of purpose like scoring thing, and that now gives us enough red flags or whatever to like drill down and be like, oh, we can actually eval this behavior out of this prompt, or maybe we need to change the architecture altogether. Does that make sense?
Yeah. Just a quick follow-up. Is that someone like Millie going very deep on like a bunch of examples?
Yes, so all this tooling that we had to write is consumed by very few people on the team. And like, we've built like a little SaaS app internally that allows them to do it. And it's really, really cool. But like now we have a channel called like Project AI Tooling, and Millie can be like, you know what, I really want this. And then I build it or someone else builds it. Like for example, these backtests now take so long to run because we're running them on so many incidents that we built something this week where you get a push notification on your phone through our mobile app if you're a member of staff to say that it's done. And like, so we've had to build stuff like that, and it's really cool. But yeah. So.
All right. Yeah. So
Have you also invested in predictive risk aversion, or doesn't that apply to the use case?
So I think that like we don't do that sort of stuff, and the people that have had some success in building products in that place are doing more trad machine learning stuff because it's similar to signal processing, right? Like it's much more like of a trad ML workload than like predictive risk. I mean, maybe eventually we'll be able to be like, you know what, that PR has the same behavior as this PR that caused that incident, but we're not there yet. Yeah, cool.
Quick question. Oh,
Yeah.
Sorry, 2 questions.
Yeah.
Really available for a chat this evening, which not here.
She's not here, sadly. Yeah.
Second one, it wasn't super clear to me from the presentation, what exactly are you trying to score? Is it whether the LLM's response is aligning well with...
Yeah, what we're trying to score is the investigation that we ran correct, and of its correctness, how strongly are we correct, right? There's yeah. So, well, I mean, it's more like there's no prizes for saying that GitHub went down, right? Like that, there's no prizes for that. So we have another metric, which is basically like difficulty. Those metrics that I showed there have actually gone away. They live on the farm. But like 6 months later, we have a new set of metrics that are like more like that. And like basically what we're looking for is the ability to root cause confidently complex incidents. Yeah.
Okay.
Yeah.
When you're doing this root cause analysis, is there a predefined set of correct answers?
Well, yeah, because we can look at the end of the incident and say what actually happened here, and we sort of take the end result and hide the working, and then we're like, how close do you get to the actual result? Yeah.
Cool.
Yeah.
How quickly are you getting new models out to production, and what's the main factors like cost, quality?
The honest answer is we get them out for general purpose tasks like pretty quickly. Where we don't is when we've if we've really iterated on a particular system, and say we have a very complicated tool call architecture because the thing's weird, like you just can't swap the model out underneath, and we'll have to it might be 2 weeks, right? Yeah. Cool.
What's the ratio for PMs to engineers right now?
We have 2 PMs and 47 engineers, I think. Yeah. Cool.
Cool. Well, thank you very much.
Cheers. Thank you.